Welcome to this video on factoring quadratic expressions when a equals 1s. By the end of this video, you should be able to remove a GCF from a polynomial expression before you factor it. You should be able to find a factor pair that multiplies to c but adds to b. And you should be able to write a polynomial expression as the product of its factors. Alright, so let's take a look at what this looks like. Let's do a little review here first. So in the past, we worked on multiplying these binomials. So let's go ahead and multiply these out. So we're going to take x times x and get x squared. And then I want to make sure the x multiplies to the other term in the other. So x times 4 is 4x. 3 times x is 3x. And then we have 3 times 4, which is 12. So when we do this, these middle terms right here are like terms and need to be combined. So we end up with x squared plus 7x plus 12. Okay, now let's take a look over here to the side. So when we multiplied these binomials together, where did the x squared come from? Where did this come from? This came from x times, there's an x in each parenthesis, so we had x times x to give us that x squared. Where did we get the 3x and the 4x come from? Well, same thing. When I distributed this first x to the other parenthesis, I got 4x, so we did a 4 times x. And 3x came right here where I did 3 times x, so we multiplied those. Okay, now where did this 12 come from? Well, when I multiplied the 3 in this parenthesis to the 4 in this parenthesis, I got 12. And where did the 7x come from? That is when I combined the 3x and the 4x, when I added them, because that's what the sign said to do. That's where my 7x came from. So this came from 3x plus 4x. This came from 3 times 4 through our process of FOILing this out. So part of what we need to be doing as we move forward with today's practice and notes is we're going to look for numbers that multiply to this n number, but add to whatever this middle number is, because that's how we got this. We got this middle number from adding these two numbers together. And those same two numbers, 4 and 3, when we multiplied them together, we got 12. Okay? So when we factor, we have this standard form of a quadratic. That is ax squared plus bx plus c equals 0. Okay, so this is our standard form where a, b, and c are numbers. They're coefficients. Okay, our goal today is we're going to look for two factors that multiply to the c value, just like we did here, but add to whatever b is, just like we did here. So we had 3 plus 4 was 7, and 3 times 4 is 12. That's our whole goal for today. And then we're going to write this in this binomial form like we started from. So we're undistributing and rewriting in this binomial form. Okay, so let's kind of take a look. So we're going to make a factor table of numbers that multiply to find the c value. So our c value here is 24. Our a value, we can't really see it, it's a 1. It's one of those understood ones. B is 10 and c is 24. So we want to have numbers that multiply to a positive 24. Now, you got to think about signs here too. To have a positive number through multiplication, you've either multiplied two positive numbers together or you've multiplied two negative numbers together. So we got to keep that in mind while we're kind of going through here. So 24, we could get that by saying 1 times 24. We could get it by 2 times 12, 3 times 8, and 4 times 6. I could keep going and it'd just be 6 times 4, which is just the same. So I don't need to repeat in a different order because we're multiplying. Now, which of these pairs, they multiply to 24. Okay, so that's what we were talking about. They multiply to the C value. I also need them to add to the B value, which is a positive 10. So either with 2 positives or 2 negatives, I need a positive 10. One of these pairs, now they have to both have the same sign. So if this was positive, positive, that'd be positive 25 or negative 25 if we did negative, negative. That doesn't work. If I do positive, positive here, that'd be 14. Negative, negative would be negative 14. That's not it. Positive, positive, it's 3 plus 8 is 11. That's close to 10, but it's not 10. And if I did it negative, negative, it'd be negative 11. If I do positive, positive here, it's 4 plus 6, which is 10. If I go negative, negative, it'd be negative 10. So these are both, this pair, positive 4 times positive 6 gives me positive 24. Positive 4 plus 6 gives me positive 10. That's the pair that I'm looking for. So we have a positive 4 and a positive 6 is a pair that multiplies to C but adds to B. Now we're going to write these factors in the binomial form and then we're going to multiply to check our work. So look at our binomial form here. Okay. Remember we were saying how we got this x squared? It's because we had an x times an x and they were in different parentheses. So we're going to do the same thing here. So we want to write this in the binomial form. The x squared comes from x times x. So we're going to split them. And then I'm going to take whatever this pair is. It's plus 4. So I'm going to put plus 4 in one and a plus 6. This is my factored form. I just undistributed to make this in factored form. So let me write here, factored form. So you know when I'm using vocabulary, this is what I'm talking about. Now let's just double check this real quick. If we go back and refoil this and we have x times x, we end up with x squared. If we have x times 6, we have 6x. 4 times x is 4x. And 4 times 6 is 24. When I combine my like terms right here in the middle, I end up with x squared plus 10x plus 24, which is what I started with initially. So this is correct. Okay, so we're undistributing. Let's give this a try again with our second example here. So remember, we're going to make a table of values of numbers that multiply to the C value. The C value is always this constant on the end. When we look at our standard form, A is always the number in front of x squared, B is always the number in front of x, and C is always the constant. Okay, so we have a C value of negative 10. When we have a negative number, and we're gonna come up with our factor pairs, that means one of the numbers has to be positive and one of the numbers has to be negative. It's the only way I'm going to end up with a negative number. All right, so to get 10, I could do 1 times 10 or 2 times 5. Those are my only choices here. So I need to see which one of these pairs, when they have opposite signs, can add to negative 3. Well, 10 and 1 are never going to get to negative 3, but 5 and 2, if I want a negative 3, the 5 is going to have to be negative and the 2 would have to be positive. So if I say 2 minus 5, I get negative 3. This is my magic pair that I want to use. Okay, so the factors that multiply to C but add to B are a positive 2 and a negative 5. Okay, now we're going to write these in our factored form in the parentheses. So to get the x squared, you had to have x times x. So we're just going to split them between the two parentheses. And then we have a positive 2 and we have a negative 5. This is our factored form. Okay, so let's just double check that to see how we're doing, to make sure we end up where we started. So we have x times x, which is x squared. Then I have x times negative 5, which is negative 5x. I have 2 times x, which is positive 2x. And then I have 2 times negative 5, which is negative 10. When I combine my like terms here in the middle, I end up with x squared minus 3x minus 10. So I ended up exactly where I started, so I factored this correctly. So we were looking for numbers that add to the b value, so negative 5x plus 2x is negative 3x, but multiply to your n value. So positive 2 times negative 5 is negative 10. All right, let's take a look on the back here. All right, so number 1 on the back, let's try this again. So normally this is what a problem would look like. There'd be a node table set up for you ahead of time. That's just, we'll just draw our own. They're very simple to make. And so we want to find what multiplies to negative 3, but adds to negative 2. So because I have a negative number, that means my signs have to be opposite from each other, because positive times a negative is the only way you get a negative. Okay, so for 3, there's only 2 factors, 1 and 3. This is the only way you can get 3 through multiplication, is 1 times 3. So if I need them to multiply to negative 3, one of these has to be negative. But if I need them to add to a negative 2, I might have to have a negative 3 and a positive 1, because 1 minus 3 is negative 2. Okay, so that's the pair that I want to use. We're going to take our x's and we're going to split them. And then we have plus 1 minus 3 for our factored form of this quadratic. It's a quadratic expression is what this is called. Okay, and we can always double check with x times x is x squared. X times negative 3 is negative 3x. 1 times x is a positive 1x. And then 1 times negative 3 is negative 3. When I combine my like terms in the middle, I end up with x squared minus 2x minus 3. All right, so let's do one more, and we can do some more in class when you're here. Let's jump all the way down to number 6. Okay, so we want to find what multiplies to c but adds to b. What multiplies to negative 45 but adds to a positive 4. So if you're going to have a negative number through multiplication, you have opposite signs. Okay, and so to get 45, we can say 1 times 45. We can say 2 doesn't go into it, 3 does. 3 times 15. 4 doesn't go into it, but 5 does. 5 times 9. So I'm trying to get to a 4. In looking at my pairs, I know that 9 and 5 are 4 apart. And I need a positive 4. That means our 9 is going to have to be positive, and our 5 is going to be negative. Positive 9 minus 5 is 4, or negative 5 plus 9 is 4. Okay, so we're going to write our factored form. We have minus 5 and then plus 9. If we multiply these back together like we were doing, we'll end up right back here. We didn't change the value, we just wrote it a different way. Okay? All right, I want to do one more in this section, and then I want to show you something that can happen sometimes too. Let's do the one right above this, number 4. Okay, so we want to find what multiplies to 49 but adds to negative 14. So I want factors of a positive 49. So that means my signs have to be the same, either a positive times a positive or a negative times a negative. That's the only way I can get a positive number. Okay, so for 49, we have 1 times 49 or 7 times 7. It's the only way to make 49. So I'm trying to get to negative 14 in the middle. So if I have a positive 7 and a positive 7, that'd be a positive 14. 14 is my number that I want, but I need it to be negative. So I really need this to be negative, negative, because 49 and 1 are never going to get me to 14. So this is the pair, the factor pair that I want to use. We're going to write this in factored form. The x's get split up, and it's minus 7 and x minus 7. Okay, and so let's double check this one, just so you can see what happens. So we have x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. And negative 7 times negative 7 is positive 49. When I combine my like terms, I get x squared minus 14x plus 49. Okay. Sometimes you'll see this. Notice they're the same parenthesis. You can see this written as x minus 7 squared. Okay. All right, let's look what happens if there's a GCF. All right, so sometimes there is a GCF involved, like we were taking out in class before. So we always need to check this. If your A value, meaning your first number is not a 1, you need to check to make sure you don't have a GCF. So when I look at this, I notice that all of these numbers are even. So I know a 2 can come out, and 2 just happens to be the largest number that I can take out. They don't all have an x, because I have an x squared, I have an x, and nothing on the third one, so we can only take the 2 out. Okay, so just like we did before, we're going to put our GCF in front, and what's left over is x squared plus 9x plus 18. Okay, now because I still have this squared term, I might not be as simple as I can go. I might be able to do more to this. So I want to use the same method that I was using before. I want to look for numbers that multiply to 18 but add to 9. Okay, so if I have 18 and it's a positive 18, that means my numbers are either positive, positive, or negative, negative. If I'm going to add to a positive 9, they're going to have to both be positive to make this work. So 18, we could do 1 and 18, 2 and 9, or 3 and 6. Those are our only choices, and we're trying to get to add to a 9. The only pair that will do that for us is 3 and 6, if they're both going to be positive. Okay, so we're going to keep the GCF out here. Can't lose them because we're just rewriting an equivalent form. And then I'm going to have x plus 3 and x plus 6. Okay, so let's just check this real quick to see how we did. This is your factored form, but we're going to check it. So I'm going to hold off and do the GCF at the end. So we have x times x for x squared, x times 6 for 6x, 3 times x for 3x, 3 times 6 for 18. Okay, so I get 2 times x squared plus 9x plus 18. And if I distribute it, 2 times x squared is 2x squared. 2 times 9x is 18x. And 2 times 18 is 36. This is exactly what we started with at the beginning, so we factored this correctly. Okay, let's try this one more time and then we'll talk about a couple in class. We're going to do number 10 because I want you to change. This is 5x cubed. Make that a 2 instead and make the 2 a 1. Okay, it was just a typo. I apologize. Now, a is not 1, so let's just check this out. 5, 5, and 150, they all have a 5 in common. They don't have x's because only 2 of the terms have x's, so our GCF is 5. And what's left over is x squared minus x minus 30. So we're looking for, let's check because this is still a squared thing. Let's see if we can break this down. What multiplies to negative 30 but adds to negative 1? So negative 30, that means the numbers have opposite signs from each other. One's positive, one's negative. So my factor choices are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So which one of those with opposite signs can I make a negative 1? When I'm looking, 5 and 6 are only 1 apart, so that can work. And the only way it's going to work is if I make the 6 negative and the 5 positive. So we'll write our GCF, and then we have x plus 5, x minus 6. And that is our factored form. We could check it. Remember, we can multiply these two together and then distribute our 5 and check it out. And it should add up to be exactly what we started with. Okay, hopefully this was helpful. We'll finish these up in class. See you there.